Welcome to Prepclass Tutors, Learning Online. And my name is Mr. Chima, and today we are going to be looking at Jamb Chemistry 2015. How are you guys doing? Hope you are staying well, hope you are avoiding the contagious coronavirus, hope you are staying safe. And now for those of you that have seen our previous video, I believe our videos have been very entertaining, engaging, and through our videos you've been able to solve some questions which you'll be finding challenging maybe in your previous study with chemistry. Now today I'm going to engage you guys in Jamb Chemistry 2015 like I said, and we are going to be looking at questions 6 to 10. This is so because in our previous video we looked at questions 1 to 5, so today we are going to be looking at questions 6 to 10. So guys, before we move on, please subscribe to our YouTube channel. Subscribe, like our videos, click on the notification bell you see there so that you'll be the first to be notified whenever we have an educational content like this on our channel. You can be kind enough to share our videos so that it will reach as much viewers as possible. Now let us go straight to business, which is to destroy all these questions. Let us destroy all these questions. Starting with question number 6. Look at how lengthy the question is. Let's see. Some copper 2 sulfate pentahydrate, which is CuSO4.5H2O, was heated at 120 degrees Celsius with the following results. Weight of crucible, that is the container they're using doing heating, it is 10 grams. Weight of crucible plus the salt, the CuSO4.5H2O salt, together 14.98 grams. Weight of crucible plus residue after heating, which simply means that some water has left the salt. After heating and some water left, this is what we have, 13.54 grams. How many molecules of water of crystallization we are lost? They're asking you how many molecules, not mass. Do you understand what I'm trying to say? You know, they're asking you the mass of water of crystallization that is lost. It's very simple. I'll just say 14.98 grams minus this. That will give me the mass of water lost. But then they're asking us how many molecules of water of crystallization we are lost. If you look at this salt, you see that this salt has 5 molecules of water of crystallization. That's why we call it pentahydrate. Penta is 5. Now, out of these 5 molecules of the water of crystallization, how many we are lost? Understand the question, not the mass. Mass is simple, this minus this. But they're asking you, out of these 5 molecules, how many we are lost? It's a technical question. Now watch. I said that mass of CuSO4.5H2O, that is the salt itself, will be mass of it together with the crucible minus the mass of crucible. That will give you the mass of the salt. Mass of the salt together with crucible as they weighed it minus the mass of crucible, 10 grams. Which is 4.98 grams. Now, mass of the residue. Now, look at what I said. I said CuSO4YH2O. YH2O simply means that after heating, some molecules of water have been lost, and it's no longer 5 again. But I don't know how many we are lost. So I now use Y. Maybe 3 we are lost. If 3 we are lost, this will be 2H2O. If 4 we are lost, this will be CuSO4.1H2O that is remaining. But I don't know how many we are lost. Do you understand? So I now place YH2O. So the mass of that residue now becomes its mass together with the crucible minus the crucible. That is 13.54 minus 10 grams will give me 3.54. I believe you are following. Good. Now, mass of water of crystallization are left. Mass. Now I use XH2O. You know, if I just assume that XH2O we are lost, YH2O we are remaining. Y can be 1, S can be 4, Y can be 2, S can be 3, Y can be 3, S can be 2, S can be 1, Y can, do you understand? So I don't know what Y is. This one is the one remaining, this one is the one that was lost. So mass of XH2O lost becomes the mass of the salt when it was wet minus what you have after it was heated. That becomes 4.98 minus 3.54. That gives me 1.44 grams. Do you understand? Okay. Now, molar mass of CuSO4.5H2O becomes Cu65 plus S, sulfur, 32, good, plus oxygen is 16. Look at it, oxygen is 16. Oh, the row 16.5. Ignore it, it's supposed to be 16. Oxygen is 16, so that's 4 atoms of oxygen, 4 times 16, then plus 5 H2O, 5 into brackets. Hydrogen is 2 times 1, 2, plus oxygen is 16. So if you add up everything, this 4 times this will give me 64. So if you add up this plus 64, you get 159.5. 2 plus 16 is 18. If you multiply by 5, you get 90. So add this to 90, you get 245.5. You understand? Good. Now, mass of wet CuSO4.5H2O divided by its molar mass must be equal to mass of that water loss all over molar mass of water loss. Is a formula I just, you understand? Just ratio this to this must be equal to this to this. That's simple. So now 4.98 divided by this, which is 249.5, must be equals to mass of H2O loss 1.44 gram all over molar mass of that H2O that was lost, which is molar mass of XH2O loss. So that will give me 4.98 over 249.5 equals 1.44 all over H2O is 18. Remember, 2H2O, 2 plus 16 is 18. So 18X, 18 H2O. 18 H2O is 18, sorry. That's 18X. That's how I got this 18X. This is the X here. H2O is 18. 18 times X, 18X. So make X a subject here. You have this times this divided by this and this. You have 249.5 times 1.44 all over 4.98 times 18. So this numerator divided by denominator, you have X to be 4.00 gram. So that's 4.00 molecules. Right? That's 4 molecules. Very simple. So the molecules of X that are lost is 4 molecules. And that means that this Y will be 1, leaving Y here. So this is 4 molecules. Our correct answer is 4 molecules. 4. So the best answer there is D, option D. 7. Which of the curves shown above represents the relationship between the volume and pressure of an ideal gas at constant temperature? Is it 1, 2, 3, and 4? Let us see. I said at constant temperature, the volume is supposed to increase steadily with a steady decrease in pressure, according to Boyle's law. So of all curves, the one that shows a steady increase that decrease is R, which is option 3. Look at it. As this one is, volume is increasing, the other one must be decreasing. So this one shows a steady increase / decrease. This one is not steady. This one is slightly going, but this one is going this way. Steady increase / decrease. So the correct answer there is R, which is 3. So 7 is what? 3. So the correct answer is 3, which is what? C. Question number 8. 12.0 gram of a mixture of potassium carbonate and potassium chloride were dissolved in a 250 centimeter cube standard flask. 25 centimeter cube of this solution required 40 centimeter cube of 0.1 mole HCl, that's mole per dm cube HCl, for neutralization. What is the percentage by weight of K2CO3 in the mixture? So we are going to ignore the potassium, what is it called? The potassium chloride, and we only consider potassium carbonate reacting with what? Acid. So from the equation of reaction, like I said, I'll consider the potassium carbonate, which is K2CO3 reacting with acid. So K2CO3 plus 2HCl will give you 2KCl plus H2O plus CO2. So from the equation of reaction, you can see that 1 mole of K2CO3 reacted with 2 moles of HCl to give you 2 moles of KCl plus 1 mole of H2O plus 1 mole of CO2. So the ratio, the mole ratio of K2CO3 to HCl is 1:2. So that what we need to do here, they're asking us what is the percentage by weight of this in the mixture. That simply means we need to find the molar concentration of that K2CO3. From that will give us the idea of what actually the quantity of the amount of K2CO3 that reacted. So we find the molar concentration of K2CO3. For the molar concentration, we find the mass concentration. Then for the mass concentration, we can now find the percentage by weight or by mass of the K2CO3. So to find the molar concentration now, CAVA over CBVB equals NA over NB, our formula for titration. So Ca, which is concentration of the acid, which is 0.1, times Va, volume of the acid, which is 40, all over Cb, concentration of the base. We don't know what it is. We don't know what the concentration of the K2CO3 that reacted, times volume of the mixture that was collected, 25 centimeter cube, equals Na over Nb. Mole ratio of the acid is 2 all over that of the base is 1. So making Cb the subject of formula here, we have 0.1 times 40 times 1 all over 2 times 25. So Cb becomes this times 40 times 1 divided by 2 times 25, you get 0.08. So if you divide the numerator, we divide the denominator by the numerator, you now divide the numerator by the denominator, we now have 0.08 mole, which is molar, which is 0.08 mole per dm cube of the base. Now we found the molar concentration of the base. Now let us find the mass concentration of the base. So we use the formula that says mass concentration equals molar mass times molar concentration. So the mass concentration of K2CO3 becomes, what's the molar mass of K2CO3? That becomes K2, that's 39, which is 2 atoms of potassium, 39 times 2 plus carbon is 12, which is this 12 here, plus oxygen is 3 atoms, that is 16 times 3. Are you following? So that's the word molar mass, then times molar concentration, which is this 0.08 that we just found. So the mass concentration of K2CO3 becomes 39 times 2 is 78, that's from the molar mass, plus 12 plus 16 times 3, 48, then times 0.08. Adding this up, we have 138, then times 0.08. Then the mass concentration of K2CO3 becomes this times this 11.04 gram. So percentage by weight of the K2CO3 becomes the mass concentration of the K2CO3 all over the mass concentration of the mixture, which is 12 gram, times what? 100 over 1. So the mass concentration 11.04 all over 12 gram times 100 over 1, and that will give us 92%. So our correct answer is 92%. 92%, that's option D. Very simple. Question number 9. Which of the following groups of physical properties increases from left to right of the periodic table? Which of the following groups of physical properties increases from left to right of the periodic table? Is it ionization energy? Is it atomic radius? Is it electronegativity? Is it electron affinity? So which one? Now I've said this, I think I said this in one of the, was it? Okay, that was last 2016 when I solved 2016 past question. That out of these 4 properties, ionization energy, atomic radius, electronegativity, and electron affinity, the only one that decreases from left to right of the periodic table is atomic radius. Only atomic radius decreases from left to right. The other 3 ones increases from left to right. Take note of that. Only atomic radius decreases from left to right. The other 3 actually what increases from left to right of the periodic table. So what actually increases from left to right becomes ionization energy 1, electron affinity 3, and electronegativity rather. Ionization energy 1, electronegativity 3, and electron affinity 4. That's 1, 3, 4 only. And we don't have 1, 3, 4 only, so there is no correct option. So I said all the properties increases from left to right of the periodic table except 2, which is atomic radius. Therefore, our answer is 1, 3, and 4 only. So like I said, we don't have 1, 3, and 4 only, so there is no correct option. So the answer is no correct option. Answer is 1, 3, and 4 only. That's the correct answer. Ionization energy, which is 1, electron affinity 3, electronegativity 3, and electron affinity 4. 10. An element Z contains 90% of Z16.8 and 10% of Z18.8. Its relative atomic mass is it 16.0? Is it 16.2? Is it 17.0? Is it 17.8? Very simple. Relative atomic mass of the elements is just simple. Its percentage occurrence, that is 90 by 100 times that particular isotope. plus the other one's percentage of occurrence 10 over 100 times the atomic mass of the isotope. Very simple. So relative, they add them together. So relative atomic mass of Z becomes 90% over the one that has 16 relative atomic mass. That's 90 over 100 times 16. Then plus 10%, 10 over 100 times the one that has 18 relative atomic mass, 10% of 18. So 90 times 16 over 100, 14.4 plus 10 times 18 over 100, 1.8. Adding these two, you have 16.2. So our correct answer is 16.2, option B, 16.2. Very simple question, very direct, very straightforward. Alright guys, we've come to the end of today's section of Learning with Prepclass, where we looked at past questions on Jamb Chemistry 2015. We solved questions number 6 to 10. If you look here, we've dropped you the link, bit.ly/Prepclass. Type this link on your browser, and when you do so, it's going to, when you type it and load, it's going to take you straight to our WhatsApp group. When you join us on WhatsApp group, you're getting updates, you're getting infos on the latest contents we have on our channel. See you in the next video. I remain Tochima. Bye.